Hello and welcome to Lesson 10-4. Today we're going to look at solving quadratics by the method of factoring. So back in the last section, we looked at solving quadratics by using the square roots. This worked very well when we had an equation that did not have a b value. So maybe you had something like x squared minus 16 equals 0. There was no b term, therefore we could use the square root method. Now, when we have an instance where we have a b value, okay, we're going to have to use something called the zero product property in order to help us solve a quadratic equation. And the zero product property is kind of like what the name indicates. It's going to take the products of the factors for the polynomial, and we're going to set those factors equal to 0. Because if this factor here is equal to 0, it doesn't matter what's in here, I know that the whole product is going to be equal to 0. Likewise, if x plus 2 equals 0, then I know that whatever I plug in for here, once I multiply those two together, it's also going to equal 0. So we are going to set each factor equal to 0, and then we're going to solve. So we'll go ahead and take a quick look at a few examples. So for example 1, it tells me to solve the quantity of x plus 5 times the quantity of 2x minus 6 is equal to 0. Well, again, because I'm multiplying two things together and they equal 0, that tells me that either the x plus 5 has to equal 0, or it tells me that the 2x minus 6 has to equal 0 in order for their product to equal 0. So now what I've got is I essentially have two different paths that I have to travel to get my two different answers. So for the first part here, if I subtract 5 from both sides, I end up with x equals a negative 5. And on the other side here, I'm going to add 6 to both sides. So now I have 2x equals 6. I divide both sides by 2, and x then is equal to 3. So my solutions are going to be at x equals negative 5 and x equals 3, okay? And if you remember, a solution is an x-intercept. This is a parabola. If I multiply these two terms here, I'm going to get a positive 2x squared. So this is a parabola that's going to be facing upward that has an x-intercept at negative 5 and an x-intercept at 3. So I could just kind of roughly estimate that my parabola is going to look something like this. Okay, we can find the vertex and all of that to be more specific, but this is ultimately what my graph is going to look like in the general sense. For example 2, I have 6k plus 9 times the quantity of 4k minus 11 equals 0. So I'll do the exact same thing, and I'm going to take my first factor, set that equal to 0. Then I'll take my second factor, set that equal to 0, because I know that one of those factors has to be 0 in order for the whole product to be 0. And I'm going to go ahead and solve. So I'll subtract 9 from both sides, which gives me 6k equals a negative 9. When I divide by 6, I get k equals a negative 9/6, or I end up with k equals a negative 3/2. Likewise, for the second one, I'm going to go ahead and add 11 to both sides. And if I divide by 4, then I get k equals 11/4. So I have a negative 3/2 and a positive 11/4. These would be my x-intercepts on my graph. Now the crazy fun part starts right now, okay? So in the first few examples, you were given the two factors. Now what we're going to do is we are going to be given a quadratic function in standard form. If it's not in standard form, we're going to make it in standard form, and we'll talk about that here in a minute. And then once we have something in standard form, what we can do is we can go ahead and factor it and set those factors equal to 0 by using that zero product property, and we can find our own x-intercepts then. Now, before you do this though, okay, you have to make sure that your equation is set equal to 0. If you have a constant over here, you are going to have to move that over to this side and make this side here, or the right side, equal 0. So we'll do an example here. So for example 3, we're told to solve x squared plus 6x plus 8 equals 0. So immediately when I see the word solve, I know I'm going to have to get x by itself. Okay, so because I have a quadratic equation and it's not factored, the first thing I'm going to do is I'm going to factor that. Now, as nice as this problem was to start out with, they did have it set equal to 0, so I can just go ahead and factor this as it stands, and I can see that I'm going to get an x plus 4 and an x plus 2. Now that I have my factors that are and their products set equal to 0, I'm going to take each factor. So I have x plus 4. I'm going to set that equal to 0. And I have x plus 2, and I'm going to set that equal to 0. And then I'm going to go ahead and solve for x. So when I do that, I'm going to end up with x equals a negative 4 and a negative 2. Now, don't forget, you can always plug these numbers back into this equation and end up with 0, and double check your work to make sure that you've done it correctly. Now, in example 4, I'm told to solve. So again, I need to get the variable by itself. 2n squared minus 5n equals 88. Well, right away, I notice that this quadratic equation is not set equal to 0. So what I have to do is I have to subtract 88 from both sides of that equal sign. So when I do that, I end up with 2n squared minus 5n minus 88 equals 0. And because I now have a quadratic equation that's set equal to 0, I can go ahead and factor this. And 2n and n, 2 is prime, so that's going to factor nicely. I do have a positive and a negative, so I know that because I have a negative 88, I know that one's positive, one's negative. And if I factor this, I get 2n plus 11 and n minus 8 as my two factors. Now that I have this factor, I can go ahead and set each factor equal to 0 and solve. And the n minus 8 is going to be a quick one. This is just n equals 8. And then here I have 2n. I'm going to move my 11 over, equals negative 11. I'm going to divide both sides by 2, and I get n equals a negative 11 halves. So n equals a negative 11 halves, and n equals 8. Okay, for example 5, again, I'm told to solve, meaning get x by itself. It's not written in standard form, so in this case, I'm going to have to add 36 to both sides. So when I do that, I get x squared minus 12x plus 36 equals 0. I'm going to go ahead and factor. I do notice right away that this is a difference of 2 squares. So this is really x squared minus, x minus 6 times x minus 6, or x minus 6, the quantity squared, equals 0. And if you prefer to do it like this, I'm 100% okay with that too. I'm just going to do it like this so I can save myself a step. So now I need to get rid of my square, and I'm going to undo that by square rooting both sides. Well, that's going to give me x minus 6 equals 0. Because I've only got one solution for the square root of 0, I can go ahead and add 6, and I'm left with x equals 6. So this tells me that my vertex is actually going to be on the point x equals 6. So what that means is if I graph this, because I only have one solution here, that vertex has to sit right there at x equals 6. Now my last example says that the diagram shows a pattern for an open top box. The total area of the sheet of material used to manufacture the box is 288 square inches. The height of the box is 3 inches. Therefore, 3 inches times 3-inch squares are cut from each corner. We need to find the dimensions of the box. Well, if you notice down here, I'm told that this length right here is x. I know that this is 3 and this is 3 based on these dimensions up here. Here I can see that this side length here is going to be x plus 2, or 2 inches, 2 inches longer than this side. So I have x plus 2, but then I also have this length of 3 and this length of 3. So if I just kind of go in and write in what I know that this whole length right here is going to be this distance x, but then I have a 3 here and a 3. So that's x plus 3 or that's going to give me x plus 6. Likewise, if I come over here, I know that this distance is really x plus 2, but then I have a 3 up here and a 3 down here, so I'm going to go plus 3, or I end up with x plus 8. So these are the dimensions of my box. So I really have x plus 6, and to find the area, I'm going to multiply these. And I'm told that the total area of the box is 288 square inches. So what I'm going to do is I'm going to go ahead and FOIL this all out and set it equal to 0 so that I can solve for the actual dimensions. So when I FOIL this, I end up with x squared. This is going to give me 8x plus 6x, so that gives me plus 14x plus 48 equals 288. Now, in order to be able to factor this, I have to write this in standard form. So I'm going to go ahead and subtract 288 from both sides. So I'm left with x squared plus 14x. Well, 48 minus 288 is going to give me a negative 240, but now I'm set equal to 0. So when I go and I factor this, let's see, I have an x and an x, because that gives me this. 240, that's going to give me, to get 24, I'm going to have 24 and 10, so I'll have a positive 24 and a negative 10, and this is set equal to 0. So when I set these equal to 0, I have x plus 24 equals 0, or x equals a negative 24, and here I have x minus 10 equals 0, or x equals 10. Well, in this case, it doesn't make sense, because I have a side length here of x, it doesn't make sense to have a negative x value or a negative length, so I can automatically eliminate the 24, or the negative 24. So I know that this side length here is going to be 10, and then this side length here is really going to be 10 plus 2, which is 12. So the dimensions of my box are going to be 10 inches by 12 inches, and then the height, don't forget, is 3, so by 3 inches. So this is a 10 by 12 by 3 inch box. Please let me know if you have any questions. Otherwise, I hope you guys have a great day, and I will see you in class.